Hey old bones, you're still no dusted off.
It is Guildmaster for you, Riven.
We did I tell ya? He's practically married to the chair.
Little early from the dungeon. What is thy business with this old man?
Aye, we found this old map of a goblin horde back in the dungeon. A nasty place, that one. Smells worse than a tool's armpit, I tell ya. Not that you helped much. Had to fight the whole horde myself. The lad near pissed himself at the first sight of the shaman. Can he help with that? Their curses are nasty. Coward is as coward does, I suppose. Who's a coward you're calling, you red fairball? I practically scouted the whole floor by myself. You can no expect a scout attack on a horde.
Enough with the theatrics. What's the map all about?
Looks like an old treasure map.
Oh, treasure. What kind of treasure?
See here, PCG Biome Core? Yeah, numpty. It's PCG Biome Core. Well, excuse me. My dad didn't have no gold for the Royal Academy. Unlike a privileged young master like yourself, they only take talent, not gold, you adult.
This PCG Biome Core is unfamiliar to me. Show me the map.
Better hurry before the dwarves start chucking chairs. Hello, adventurer. PCG Biome Core. An interesting name and quite an interesting framework as well. If you've at least seen the plugin before, it may seem quite intimidating at first. That's why I'm here to make it simple for you. This video will be part of a several part series where we will take this apart bit by bit. We'll start with the basic terminology and see how it works at a fundamental level. Then we will move on to the main graph that's doing all the heavy lifting. It's called the Biome Core graph. After we have a tiny bit understanding of the plugin, we will create our own biome setup. The PCG in PCG Biome Core starts with the word procedural. But what if you want to control it manually? Well, the next part is just about that. After that, we'll move on to slightly advanced concepts, going in detail about some of the components of PCG Biome Core. Moving on, I'll also casually mention the manual paint part. Yeah, it's nothing special, just sampling different parts of the paint layer and referencing them to things that we learn in the earlier parts. And finally, we'll learn about the Biome Core runtime. This one's, it's nothing special either. It's the micro scattering around your character, like the grass or the smaller foliage that spawns wherever your character goes, or the creepers hanging off your trees, or the small weeds growing on the boulder going along the river shore, or deciding whether a plant supports growth around itself or it just leaches off the minerals. I mean, who even need minerals? I haven't seen potassium in like months. Oh, we've reached the little red mark. Let's get started with our introduction. So to understand anything, what do you need to know? You need to know the what, why and how. Let's start with the first part, the what. What even is PCG Biome Core? The PCG Biome Core is a data-driven biome creation tool made of native PCG framework nodes and graphs, and it makes use of data assets. Now the tool has been built with a systematic approach, providing a fixed pipeline organized in logical sections with customizable steps. This is the official definition, like literally taken right out of the docs. But what does those fancy words even mean? Hopefully, you have a basic understanding of PCG framework tool. because it will be a little bit useful in understanding the PCG Biome Core. It's basically saying this. You get the data, you sample, you do your own thing in between, then you finally spawn. What's different in PCG is that the data that you are inputting here, like what to spawn, how to spawn, what to do in between, and then finally an output. That data is laid bare and at your whim. Do whatever you want to do with that. But in Biome Core, it's a bit more organized and customizable wherever you need it to. If you want to take an example, let's say PCG framework is a factory. From the factory, you need a certain product. PCG Biome Core is a mold for that product. It takes in raw material, shapes it however you want, and then gives you the desired product. So a mold, that is bare bones setup, to get your product by giving it raw material, that is your data, and getting a final output. It's a standalone plugin. It doesn't need anything other than PCG framework. It has everything it needs, like data assets, structure, and PCG graph, and all those combined work in a central core graph. We call it PCG Biome Core graph. All of it works together to create your biome. Going back to that factory analogy, there's also a sample product created from you from our mold, which is PCG Biome Core. It's called the PCG Biome Sample plugin. It's its own plugin. It only needs the PCG Biome Core and everything PCG Biome Core needs as well. It's an applied version of the PCG Biome Core plugin. Now that we understand the what, next we need to know the why. Why do you need to use the PCG Biome Core plugin, another plugin on top when we already have the PCG Framework plugin? Can't we just use that instead of getting all fancy? So let's talk about the features of PCG Biome Core. Perhaps the most important of it all is it saves time. It comes with a lot of bare bones stuff. Next, it's data driven. You use different data assets to pass in the data. You can even copy and modify the same data asset over and over multiple projects. That again saves you a lot of time. Next, it only uses native PCG nodes. There's no custom code or added custom blueprint. It's quite organized. It has its logic, like you generate points, apply biome filter and all that. We'll talk about it when we are overviewing the Biome Core graph. Next, you can create any number of biomes you want. You can have a grassland, desert, coniferous forest, a temperate forest, swamp, anything. The only limit is your imagination and maybe performance too. And to control your created biomes, you have a bunch of class, structure, data assets, volumes, splines, anything. And all those data assets, they are stored in a root asset table with all the parameters that are used to control those biomes.
What is a root asset table?
What is a data asset? You're hopeless. We'll learn all those fancy words later. Oh, and all that biome data, it's generated in a 3D space, meaning you can layer biomes. That's right, you can have a sky island floating above a temperate forest which has a tunnel going down to a cave system. All of it can be defined using custom data such as volumes, splines, even texture. It's calculated everywhere globally and stored in what we call a biome cache. And we can spawn stuff based on priority, like biome A has higher priority than biome B because A is for apple, so wherever those two biomes overlap, biome A will win out.
Oh no, no justice for biome B in this cruel, cruel world.
Moving on, you can blend between different biomes based on a parameter that allow overlapping over a certain distance. Next, you can have manual control over all these procedural nonsense. Like if I want to put a city here, like every other little human, I'll cut down the forest and then place my city there. But then what if I want my city in the forest spawn different stuff than the city based in the swamp? Yeah, you can do that. And why do you have to be limited by mesh? You can spawn mesh assemblies or any other actor. Say you want different background track in each biome. Would be weird to hear birds chirping in a swamp. Not really, but you have a choice. Moving to the next reason, if we debug this, right here, you can see the mesh bounds. Not exactly pretty, you'll have to adjust them based on the mesh you spawn, but Biome Core would do that for you. Any bounds that are generated there would be based on the mesh it belongs to. And from there you can even further transform them, regular PCG stuff, which brings us to the next advantage it has. Since it has mostly perfect bounds based on each mesh, so if there is like a small sapling and a tree, then any interaction between them would be what you would generally expect. All in all, you don't generally need to adjust the bounds out of the box. Next feature, generator subtypes. Fancy word, this one. So once you've generated a particular asset in a biome and you need further control over the distribution within the biome, because say a forest doesn't just have trees spawning all over, there are first clearings or a flow area where there are debris flowing across, or maybe there is a soil area that's different from the regular forest ground. That's where generator subtypes comes in. With it we can control like which layer certain assets of that biome belongs to. So yeah, that's where the biome painting part comes in. After you assigned which layer it belongs to, and then you start painting that particular layer, and it will auto update based on the rules you set earlier. Next, children. So when a man and woman love each other, oh, that's the wrong plot. Right. So a tree in a forest pops out a bunch of seeds around it, and from there the saplings grow up, and you want to simulate that. So you take the parent, in our case the tree, and transform and duplicate it multiple times, and those are your children. Then further those children can have more children of their own, and before you know it, an entire generation. So let's move on to the next one before a stock comes in. Filtering. Any point that you generate, you can then further control it with filters such as density or height, and you can even use textures to control the filter process. And finally, runtime hierarchical generation. It is just as the name suggests, you can partition and generate your stuff with the hierarchical generation. So hopefully Biome Core has piqued your interest by now. So that's the what and why, and the how. The whole series is based on the how, and we'll explore it bit by bit. Let's start by creating a blank project. Let's rename this Crow Biome Core and create. What do you need for the PCG Biome Core to work? Obviously the base plugin. Let's open it, and PCG Biome Core. And as mentioned earlier, the PCG Biome Core is based on the PCG framework, so we'll need that as well. So let's turn that on. Yes. As well as the PCG Geometry Script Interlock plugin. Or just search PCG and tick everything in sight. That also works. For now we don't need any other plugin. There is maybe one more, the PCG Biome Sample. Going back to that factory analogy, this PCG Biome Sample is one product. Later in the series, we'll create our own product based on our needs. But it's still a good idea to toggle it because we'll copy some of the stuff directly from there to save some time. And then if you need to modify some stuff, we can do that as well. After restarting, next let's go to our content drawer and make sure show engine content and show plugin content is turned on. After that, let's go to engine, plugins and find our PCG Biome Core. Let's add it to favorites so it's easier to navigate back and forth. Let's also add the biome sample content as well. By clicking here, we can easily navigate between the two. And to our main content folder, let's create a folder and call it game. Change the color a bit. And let's create our biome tutorial folder. Pro tip, create a global folder and keep stuff that you regularly want to use or copy between multiple biomes. Anything you want to reuse, put that in global. Since this is our first biome, we'll mostly put everything here, but as you create more and more biomes, you'll see which stuff you are using regularly and then you transfer that over to the global folder. Let's also add this to favorites. Would be much easier to navigate between all three. And if you have anything to copy, just grab it and directly place it in the folder, and from there you can move it wherever you want. For now, let's look at our Biome Core content folder. Quite a lot of stuff here, and we'll explore mostly everything till the end of the series. For now, we don't need everything. Let's start with the backbone of everything, the Biome Core PCG graph. This is the entire logic for the Biome Core. And how do we deliver that logic into our world? That's our BPPCG Biome Core. You'll place this blueprint whenever you want to use the Biome Core graph. Let's open a new level and drag and drop our blueprint. This is nothing special, just an actor that has a volume to define the bounds and a PCG component that has the main Biome Core graph. Let's center it and scale it by default it's 1024 meter by 1024 meter by 256 meter. You can scale it to your landscape bounds or not. If you are just creating stuff and your landscape is quite big, let's say 8K or even 4K, you don't need to have it cover everything, because the biomes are defined either by a volume or a spline, which should be inside that volume. Let's scale it by 2048 meters, so 2048 by 2. And in the Z, let's do 512 meters. That's the limit of the landscape by default. Our landscape here is 2017 meter by 2017 meter. It will obviously be bigger, but then again, it doesn't matter. The texture will be projected based on the landscape if you are using that to define your biomes. And since it's inside, it doesn't matter. But if you are one of those people, you can put 2017 by 2 to match it exactly to the landscape. Next, let's go to our PCG component and start an initial generate. After this, anytime you make a change, it will automatically reload. So this blueprint class will execute our logic from the Biome Core graph based on different data like the asset, filter, children, everything. The Biome Core has a bunch of global parameters. The one we are looking for is the debug for the biome cache. Since we don't have anything set up, it's empty. Everything is black. Oh no, this part is white. It's not actually, this is just the landscape clipping through. We should give it some biome data. We can use a bunch of methods. Let's use a spline and a volume. Right now the volume or spline are not defining anything, but we can use biome definition here. Let's say our broadleaf forest, it turned green, which is the biome color of our broadleaf forest. For now, think of it as just finding the biome and assigning a color. Let's also select our spline and give it a definition. Let's say coniferous, and it turned blue, which is naturally the color of coniferous biome. So this is the biome cache, and anytime you want to debug it, you just take this. The sample content has a sample map. You must have seen this at one point or another if you looked into Biome Core. But this is just the sample map showing us how things work. Since creating is learning, we'll of course create our own and learn from that. Sure, theory helps, but practical application is where all the rage is. So let's start with some basic stuff. Create a new folder. Let's call it biome asset. This is the stuff that spawns. So in this case here, the tree is our biome asset, the spruce is our biome asset, the cactus is our biome asset, the boulder, and so on. Let's create another folder and call it biome definition. I explained the biome cache earlier. Let's turn it on. The red area is the desert, the green is a forest, and all of that is defined in here, the biome definitions. Let's create another folder and call it biome generators. They generate the root points. So how the cactus is spawned, how the trees are spawned, all of that is handled in here. Let's create some stuff to get you more familiar with this, and we'll start with the easiest of them all, biome definition. It's a data asset, so let's go to miscellaneous and data asset. For the class, we'll select biome definition template. It's defined in our biome core. We'll select this and let's just name it forest. Let's check the class. We'll go to biome core, definition, and inside setup, this is where the parent for our data asset comes from. It's based on this biome definition structure. And if we go back to our data asset and open it, so the structure defines a biome name, color, and priority. Let's name it forest and give it a green color because forests are green. Let's duplicate this and call it grasslands. Let's also rename that and give it a yellow color. Next thing to set is the priority. If two biomes are overlapping, let's go back to our biome cache. On the border here, each 3D cube has only one biome. So if there are two biomes existing on the same point, then the biome with the higher priority will win out. Higher priority here would mean a lower number. So if we give it a priority of 1, this one has a priority of 0. So if grassland and the forest biome are present on a single point, then grassland would win out. Just make sure each biome has its unique name and color, which would then show up in the biome cache. So that's about our biome definition. Let's come to our biome generator. Once again, a data asset. And for this one, we'll use biome generator template class. Let's name it biome tutorial default generator. Open it. It's defined using a structure in our, let's go to the setup here. This is the parent for our data asset and this is the structure which shows up in our data asset. Now these properties define our generator. We can basically create a bunch of template generators. For example, trees have a different growth pattern than shrubs, which have a different pattern from rocks. So we can create different generators for each one of those. And even trees don't spawn all the same. Some trees are dense, some trees are sparse. So you can create different generators for those as well. Now what the generator needs to generate anything is a generator type. It's a unique name given to a generator, so we can easily identify it later For now, let's just give it a default name. Just like biomes, generator also have a priority. Next, it also needs a graph. This graph is where all the logic of how a biome asset spawns. In the setup folder of biome generators, there is graph, and we'll use the template graph. So this is one of our generators, and we'll create a graph folder where we'll use our own logic or use some existing graphs. So let's do that and use a PCG graph instance. Let's call it PCG default generator. And in here, let's use the same template graph. So anything that graph has exposed, we can control from here, which in turn will affect our generator. Let's put our newly created graph instance in our default generator. So you can create one graph, expose its parameter. So in the earlier example, when we used the example of sparse and dense trees, you can basically make a tree spawning generator and then use point per square on one of them to make it dense and on another to make it sparse. So let's at least create two default generators. The second one would be the denser one. And in the parameters, let's override BPM and let's say 0.8 or 0.7. Let's also lower the point extents to 100. Save it. So logically, these are two different graphs with their different generation pattern. Let's duplicate our original generator and call it dense. And instead of the same graph, let's use the denser one instead. So far we have created two different biome generators. These would be useful later in the biome asset. You can at any point open it and see what's happening behind the scenes. I'll save the explanation for when we are discussing the biome generators. So with the biome generators done, let's move to our biome assets. Again, let's create a data asset. For the class, let's select biome asset template and let's give this an identifier before the name, so you don't confuse it with anything else when you are assigning the biome asset. That has happened to me more times than I'll ever admit. Let's add an entry to the array. And what this needs is, first of all, it needs a generator to tell it how those points are spawning. So let's use the default generator here. And it needs a mesh or a data asset or an actor. We'll use this for a forest. So let's give it a tree. Save it. Let's make another data asset for our grasslands. We'll duplicate the same one. Name it grasslands. Open it. And in here, let's give it maybe a sapling. Only generator and a mesh are needed to spawn anything with a data asset. In grasslands, we'll use this to spawn the sapling based on this logic. And in forest, we'll spawn a tree using this logic. We'll change this one to the denser one. This is an array, so you can use as many assets as you want. And even use different generators for each of them. And it comes with a bunch of controls. We need a bit more understanding of the system to understand each one of them. That should be enough for now. And in the Biome Core, you can check out how the parent is set up. So our template biome asset is based on this structure. And inside the structure, it uses some other structure that are defined here. It uses this filter option structure within the biome asset. And it's a bit more complex because there are a lot of things to control. And we'll deep dive into it later. For now, let's go back to our open world. Let's set up a basic biome in this world. we'll use the blueprint BP PCG Biome Core. Let's create our own blueprint class here. And for the class, we'll search for that BP PCG Biome Core. Select this, create, and let's call it BP Crow PCG Biome Core. Let's open it. First of all, let's make sure it's not spatially loaded. Untick this. Then make sure it's using the graph that you want. By default, it's using the Biome Core PCG graph. Let's copy it because we are going to change a few things in here. And I don't want to mess up the original. And let's call it Crow Biome Core. And it's already updated here. With that, let's compile and save. So let's bring it in. Let's again center it and click generate. Again, let's open the biome cache. Nothing so far. So let's go back to our Biome Core blueprint folder and let's drag in a volume and a spline. In the spline, let's use the definition we created earlier, and forest goes under definition. So it turned green, which is the color of our forest. So it's working. Next, for our volume, we'll use the grassland definition, and it turned yellow. Obviously the color of our grasslands. Would be a shame if it didn't. Then I'd have to go back and find that silly mistake I made. Probably would have edited that part out. So with the biome defined, let's give them some assets to spawn. So for our grassland, we'll use the grassland asset. Make sure it's under the assets and not the runtime asset. A mistake that I might have repeated a few times. And for our spline, let's use the forest. Let's turn off that biome cache. See if it's spawning. Lo and behold, we have the trees. In the volume, the saplings are also spawning just fine. And like the generator said, trees are dense and saplings are sparse. With the biome asset, we can control it based on a bunch of parameters. So let's see the generator doing its magic. We used the denser one for our forest. Let's change it back to the default one, which did nothing. Did not change anything, sadly. Let's open the graph and change a bunch of stuff. Let's lower the ppm to maybe 0.1. Maybe it's a point extent thing. I'll at least refresh the Biome Core. So let's lower it even further. Yeah, that worked. And for our grassland asset, right here, let's use the denser one. Let's make it a bit bigger. And dense. So there are a lot more points here. Congratulations! You just created your first biome. First of many. That was a decent introduction, In the next part, we'll explore what the Biome Core graph is doing, how it's doing it, and how all of this works. I'll rest my big brain for now. I'll see you next time. Until then, enjoy what you're doing.